if I post the same quiz over this chapter that I have in the past, it's got several questions that hinge on this little fact, which is that if you have something like this, if a is equal to 3, and then you have some code here, and then you have something else here, that is not a syntax error. If a is equal to 3, let's just pretend that these are print statements. I mean, I know that's not C#. It should be console.outline, whatever. But what would this print? Assuming it was good syntax.
3.
If a is equal to 3, and then so a is equal to 3, so it's going to print a, and then it's going to print b. What if a is something else? What if a is equal to 4? What is it going to print? It's still going to print b. The reason it's going to print b is because C, C#, Java do not care about tabs. So it's treating it like that. So if a is equal to 4, it's going to skip this if statement, but it's going to go ahead and do that. Doesn't matter that it's indented or not. You'd get the right answer, right? Automatically in your head. If you saw it like that, you would know which one it was going to print. If a is equal to 3, it's both going to print a and b. If a is equal to 4, it's going to come down here, skip that one, and print b. Same is true. It's worded like that. Tab doesn't help it. Tab is just confusing at this point. So the thing after the if statement header, if it's not a block of code, the only thing that's subordinate to it is the first statement. The rest of them are not. Even if they're tabbed over, they're not. They're not part of that block. And if you need to execute more than one statement, it's part of the if, then you put your curly braces there, and then it'll work. So you can use nested ifs. If the number is greater than low, then if the number is less than high, then do something like this. If number greater than low, nest it. If number less than high, print this number is between that and that. Now nested ifs can usually be replaced with an and statement. If you have this, if num greater than low, and then if you have if num, come on, I think I got those reversed. If the number is greater than low and the number is less than or equal to high, then it's a good number. So we could, console.outline, .rent, yes, whatever, right? You could replace that with and. You use and to replace nested ifs if it makes sense. In which case it'd be if num is greater than or equal to low. And, that's how you spell and in this language. And the number is less than or equal to high. Then you could console.out, .write line. Yes, like that. These two chunks of code do the exact same thing. One thing to note about that is that if this check is false, it doesn't do this check. I mean, that makes sense, right? If this check is false, it's not going to then check this one. So if you have two checks that can take different amount of time to run, like they're calling some kind of function, and one takes a relatively long number of cycles to process, and the other one takes a very short time to process, you want to put the one that runs quickly first. Or you want to put the one that is true least often first. Because if this one is false, it can rule this one out immediately. So you want to put the check that is the least expensive in terms of processing time, or the one that is true least often first, if you have nested ifs. The same is true when using and. If this part of it is true, then it does have to go on and check this. But if this part of it is false, it skips this check. So if we can rule out 99% of the cases by putting the one that is most often false here, we get a speed improvement. So a dual alternative is just when you have an if and then you have an else. If you have one line of code, you don't have to put curly braces around the block. If you have more than one line, you must. So if something is greater than high, print, yep, that's greater than high. Else, print, not greater than. So you can combine multiple decisions into an if statement using and or. Now you can create expressions that are a little bit too complex by throwing in a whole bunch of ands and ors, in which case, you may be working against yourself. But the conditional and operator, it is true if both operands are true, if both expressions are true. I wonder what that was supposed to be. Must. Come on. Must include a complete expression on either side of the operator. So when we're checking this out, this means and. It means that this side and this side must both be true before that will execute. So this is a so-called truth table for and. Here's what the and truth table looks like. Is if you have two inputs for it, and then the operator is and, then here's the result. I'm going to use zeros for false and ones for trues. If they're both false, then the result is false, right? If both of these were false, we wouldn't print yes. If one of them is true, then the result is still false, right? Because if the number is greater than lower, but this part's not true, it's not going to do that. Just like up here, if that part was true but that wasn't, it's not going to print that out. So if one of the operands is true, the result is still false. If the other one is true, but the other one's false, the result is false. Only when they are both true is the result true. The only time that this expression works is when both sides of the ampersands are true. And these must be complete expressions. When it gets to or, people think that something which, like this ought to work, and it doesn't. X is equal to 3, and then if x equals 3 or 4. No, that doesn't work. There are things that you can express in the English language that you can't write in code like that. Here's another one that people will do. If 1 is less than x is less than 10, right? That's supposed to be checking to see if it's between 1 and 10. That doesn't work either. The deal with the ands and the ors is that both expressions, both sides of the expression, both sides of the and operator have to be complete expressions. If x is equal to 3, equal 3 or 4, well, this one's valid, right? That's a valid expression, but if you remove that, what does that mean? If 4. If what 4? That's meaningless. So if we make that if x equals 4, and we go ahead and put that back in there, now it's good. Now we're good to go. If x equals 3 or x equals 4. So in a way, the and, in a way, or can be used to replace multiple if statements. If we have this nested if statement, often we can replace them with and. If we have multiple if statements in a row like this, if x is equal to 3, do something. And then if x is equal to 4, do something. Well, if x is equal to 3 or x equals 4, do something. Now obviously that's not good C# code, right? There's no parentheses and semicolons and stuff like that, but logically. So and can replace nested ifs, or can replace multiple ifs if they were checking on the same thing, right? If the outcome was the same thing. If this was if x equals 3, do something, if x is equal to 4, do something else, then you couldn't combine them like that. So for and to work, both operands of the and operator must be true. In other words, both sides of the and expression. If either one of them is false, if that's not true or that one's not true, it's not going to print yes. Or is a little bit different. Or means one or the other. Just like this. If we have if x is equal to 3 or x is equal to 4, then console.out.writeLine, yes. Well, if that's true, doesn't matter what that is. It's going to print out yes. If that's false, well, then it goes ahead and checks that one. And if that one's true, it does that. Or, right, if you are sick or tired, stay home. You get to stay home in either case. If you're both sick and tired, great. So much the better. But only one of those have to be true because of the or word. So and is represented by that, or is represented by that, and the truth table for or, we could make another one. X, Y, and we are oring them, and the result 0 or 0 is going to be a 0, right? If both sides are false, then it can't be true, right? If that's false or that's false, it's absolutely not going to do that one. How about 0 or 1? Well, in that case, the result is true, right? Because if that's true, then it's going to go ahead and do what's after that. Or if the other one is true, you know, if that one was true and that one was false, it would still go ahead and do what's underneath it. Better put something there. And so much the better if they're both true, right? So if you look at it and you're using and, the only time it's true is when both sides of the expression are true. For or, the only time it's false is when both sides of the expression are false. Don't know if that helps or not. Just like when you use and, you can kind of optimize it and say that, where's one of our expressions? You put the one that's most often false true in order to speed it up, right? If this one's false more often than that one, then it's more efficient to put it here so that we can rule out as many checks as possible, because if this one's false, there's no reason to check that one. The same is true of or, but in reverse. You want to put the one that's more often true first for efficiency's sake. Because if this is true, there's no need to check that one. So if this is true 99% of the time and this is true only 1% of the time, we'd want this one to be here first. Because we don't want to have to keep checking things that are false in order to get to the next one to find out that it's true. That takes twice as long. So efficiency rules or optimization rules. For and, put the condition that is least often true first. If A and B, A should be the expression that is true less often. For or, put the expression that is most often true first. If you do if A or B, then this one should be the one that is true most often. Because if this is true, it doesn't bother to check that. And if we can rule out checking two things, you know, if this one was false most often, then it would have to come over here and check. It's better to do it reverse. So that's called short circuit evaluation. Short circuit evaluation is that when part of the expression is true, it can skip doing the rest of it. Doesn't do that one. Or when you're using and, if that expression is false, it skips that one. Now usually that's not a big deal, but if these were actually function calls, it could be a really big deal. Like if you wrote something like this, I don't know, if you call function A and you check it equal to 3, and then you call function B and you check it equal to 4. I should be calling them methods, but you know what I mean when I say functions. If this is false, it's not going to call this. And if you wrote your code in such a way that you thought that that was going to happen every single time, and that this was going to happen every single time, you would be mistaken. Because if this one was false, then this one would not get evaluated. Here's another example. What if you did this? If x plus plus equals 10 or y plus plus equals 10. And you thought that both x and y were going to get incremented every single time this was evaluated. No, this one will get evaluated every time. But if this one's true, it's going to skip doing that one, and so y would not be incremented. This is a little bit too clever by half. I wouldn't necessarily do that, but some people, you know, some C programmers like to get really wild and crazy with putting their increments and stuff right inside the expression that's going to be evaluated. And just know that if you're doing logical operators like and or, then you have to take short-circuiting into account. Short-circuiting into account means that if this part is true, then that part's not going to even happen, and y wouldn't get incremented. So short-circuiting the expression is evaluated only as far as it needs to. Before proceeding to the next. In the above case, B subscript call would not happen if A subscript returned false. In the above case, here, y plus plus would not happen if the x plus plus equals 10 is true. So that's an argument perhaps for not incrementing your stuff in complex expressions. And I would certainly say that that's a good thing. I don't tend to throw in, you know, modifications of my values while I am checking them there. So here's the and truth table expressed as trues and falses as zeros and ones, but it's the same thing. The only time that x and y is true is when x is true and y is true. Otherwise, all the other combinations are false. And the conditional or operator, you write it using two pipes. That's the shift of the backslash key underneath the backspace. You must include a complete Boolean expression on either side of the operator. I mentioned that you can't do if x equals 3 or 4. You got to say if x is equal to 3 or x equal to 4. And again, short circuit evaluation. Only as much of the expression as necessary is evaluated. So if the part in front of the the part in front of the or is true, then it won't do the rest of it. It'll just go ahead and say, yep, it's true, and keep going. Not totally getting what this is saying here. I mean, I get it, but use and to replace nested ifs, and these are not nested. Well, I suppose they're nested. The consequences there. I'm not liking it. But what we will mention is, let's go ahead and start some code. Doing range checks, range evaluations to see if something is inside of a range or outside of a range. This is lecture H, I believe. C++ lecture G. Why don't I just go look? Yep, this is lecture G. So I need it to be a C#. You know how to do these. We're not going to do anything fancy with a GUI, so just choose a console app of the various console apps. We want the one Are there not two options on your screen? And remind me which one it is. I only have one of them on mine. There's console app, and then there's console app with framework or something like that. Tell everybody the same one. I wish we had the same one. Okay, but that's for forms. Console, app, net framework. Yeah, that's right. Okay, so on your choices, if you've got Visual Studio 2019, you're going to choose Console, App, Net Framework. I just don't have that choice. It's the only option I have. But you'll choose Console, App, Net Framework. So, for range checks, to check within a range, you use AND. To check outside a range, use OR. And yeah, you can always do things in more than one way, but that's generally true. So for example, if we have an age variable, and we ask the user to fill in the age, which I'm not going to do, right? If we want to see whether they fall between two possible values, like let's say that grade school is only between the ages of 6 and 12, let's find out. So if if parentheses age is greater than or equal to 6, ampersand, ampersand, age is less than or equal to 12, close parentheses, C W tab tab console.writeline grade school. We used AND to check within the range. What if we want to see if something is outside of a range? Make sure you know that they're not too young or they're not too old, or the temperature is outside of a specific range. Let's declare another variable called temperature, and if we want to see if it falls outside of a specific range, like freezing and boiling in Fahrenheit is 32 and 212. So if temperature is less than 32, or the shift of the backslash, temperature is greater than 212, CW tab tab not liquid, end quote, end parentheses semicolon, else CW tab tab liquid. Like that, right? So we have checked within a range. Now if you wanted to argue about it, you could say that you could check outside of a range just by throwing a not in front of it, right? If you wanted to see if it was outside of the range of 6 and 12, then you could do, that. And yeah, I'm not going to argue with that. In general, the easiest way to do a range check is that if you're checking within a range, use AND. If you're going to check to see if something falls outside of a range, use OR. So combining AND and OR, the thing you need to be aware of is just like addition and multiplication, they have different precedents. So you can use parentheses in order to force them to evaluate in the correct way that you want. So for example, here we have if age is less than child age, or the age is greater than the senior age, and the rating of the movie is G, then we tell them that they get a discount. So I guess children and seniors get to go into G-rated movies at a discount according to this logic. Why did we have to use a parentheses around that part? Because AND has higher precedence than OR. So it would have done this part first. It would have done age greater than senior age and rating equals G. That would have been the very first part that it figured out. Just like if you have 1 plus 2 times 3, the 2 times 3 gets done before the 1. And so why is that? If we go back and we look at our little truth tables that we came up with way up here, we could think of ampersand as being a logical form of multiplication. What do I mean by that? 0 times 0 is 0. 0 times 1, well, anything times 0 is still 0. 1 times 0 is 0. 1 times 1 is 1. So and can be thought of as logical multiplication. And if you go and take a logic course, at some point you're going to see that it is notated like that. Like if clauses A and B are true, you can do it like that, and that means A and B. Well, if that's multiplication, then this is addition. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1, well, this is a world in which we only have two possible outcomes, 0 and not 0. So 1 plus 1 is also 1. So I'm going to scroll down at the very bottom here and make a little parenthetical comment. And is considered logical multiplication, or is considered logical addition, and which has higher precedence, multiplication or addition. Multiplication has higher precedence, right? If you have 1 plus 2 times 3, you know what's going to happen first. The 2 times 3 is going to happen first. So if you have A or B and C, then this is a part that's going to get evaluated first. Then that will become a result, a true false expression that will be ORed against that. And if you didn't like that, if you wanted it to be like that, you'd better put the parentheses around it. So, and has higher operator precedence than or, just like multiplication has higher than addition. You can always use parentheses to force the issue. I would use parentheses even if it would happen to evaluate the same, with or without them. This expression here, it could have been rewritten. No, it couldn't have. I was about to say it could be rewritten without the parentheses, but only if we did some cheating. Yeah, just use parentheses when need be, and even if it's not strictly necessary, it's not a bad idea to do that. Not a bad idea to throw the parentheses in, just so that the person reading your code understands how it's going to process, as well as the compiler knowing. So we've all have already used ands and ors, but if you haven't taken C++ or Java, you probably haven't done switch. Switch works like this. Let's declare a variable, string grade, and then we're going to ask the user for their grade, but not really, because we're just going to arbitrarily assign it A. We should let the user input this. I guess it wouldn't take that long because we don't have to do some conversion. Well, let's do that. Let's tell them CW space space console write line, enter A, comma B, comma C, comma D, comma or F, end quote, in parentheses. And now let's read in the input. Grade equals console.readLine parentheses in parentheses. Okay, we have a grade, and what are we going to do with that? If they made an A, we're going to print out 90 to 100. If they made a B, we're going to print out 80 to 89. If they made a C, we're going to, it's kind of the reverse logic of what you normally do, right? But anyways, so switch based on the value of the grade. Kind of like a television knob. If it's set to 1, you're going to do something. If you're set to 2, you're going to do something else. If you're set to 3, you're going to do something else. Well, if this is set to A, that's the A case, and we're going to print something out about it. So CW, tab, tab, 90 to 100, end quote, in parentheses, semicolon, break, semicolon. We're going to do the same thing for B and C and D and F. Maybe we'll only do a few of them though. B colon, CW tab tab. What are we going to write out? 80 to 89. 80 to 89.9, whatever. End quote, in parentheses, break, semicolon.
case, colon, C, not colon, case double quote, C, end quote, colon, CW tab tab. If they made a C, we're going to print out 7279.9, end quote. And then we're going to break. That keyword break is necessary. Some languages let us get away with not having it,
and it does something very specific and tricky if it's missing. C# just flat out demands it to be there, and it doesn't do what those other languages would do if it was missing.
Well, it's not going to take much more time to do the D, so in the F, so why not? I'm going to highlight those two,
paste them. So this is going to be constant. Notice it underlined it as an error when I copied and pasted. It's because you can't have two options that are the same, right? It wouldn't know which one to do. So we'll make that a D. And if it's a D, they made a 60 to a 69.
And an F. So I'm going to paste one more time, and I'm going to say below 60. And what if none of these were true? That's the default case. None of them were true. They gave us some bad input. Console.out.writeLine, parentheses, quote, invalid grade entered, end quote, in parentheses, semicolon. And you don't have to do a break after the default version, but it doesn't hurt. Okay, so there's our switch statement. Like a television knob switches which station you're going to be watching.
Based on the value of grade, it's going to do either that, or that. We could prove it. Let's go ahead and run it.
So, enter an A, B, C, D, or F. What if I choose none of the above, right? I choose G.
Well, since I didn't put my read line at the bottom, I didn't get anything. So why not?
This is the end of the switch right there. I'm going to add that as a comment. I'm going to add the console.read line down here at the bottom. Console.read key or read line, whichever one you like. And this is the end of main. This is the end of the class. And the last one is the end of the namespace. Run it again. All right, so if I type in G, it says invalid grade entered. I run it again, I type in a C, it says 70 to 79. So it's just like a great big stack of if statements.
If the grade is equal to A, do that. Else if the grade is equal to B, do that. Else if the grade is equal to C, do that. Now if you've taken other languages with switch statements, you've heard of fall through.
Fall through is what happens if you leave the break statement out.
What happens then is that say it was equal to A. It would jump here, it would print out 90 to 100, and then it would fall through and also print out 80 to 89. Then it would hit the break and leave. C# does not support fall through, but yet despite them not supporting fall through, they require you to add the break statement anyways. So just accept it as a matter of given. Every case is going to end with a break, with the exception of default if it's the last thing in the list. Default doesn't have to be the last thing in the list. We could cut it and paste it up to the front and it would work just as well. Okay, so that's the way the switch statement works. The thing between the switch, and I'll print it out for you so you don't have to worry about it not being on the screen right now. The thing between the parentheses and the switch can be one of these values. Strings do not work in C++, so if you're coming here from C++, you may be surprised to see that string is an acceptable switch type. However, it is for Java. and it's just not available in Python. You can't do switches in Python. So this variable here has to be a discrete type. It can't be a float. It can't be a double. But it can be pretty much anything else, you know, some kind of integer or a string or a character, anything that can be discretely compared. If you had to make it a double, I guess you could multiply it and do something else. Like what if you wanted to do the reverse, whoopsie, and write a program
that asks the user for a grade from 0 to 100, and then print A if the grade is, you know, 90 to 100, B if it's less, you know, if it's 80 to 99, and so on. But we really wanted to do it for whatever purpose with a switch statement. We could do that. But we'd have to convert that grade into a smaller value that could be compared. So like if they typed in, you know, grade is equal to 89, if we made an integer version of it, right, I'm just going to call it GR, is equal to the integer version of the grade divided by 10, then it'd be pretty easy, right? Switch based on GR, and then if it was a 9 or a 10, you could print out that it was an A, right? So that'd be a case. So if it was a 9 or a 10, you could print out that it was an A. I'm getting tired of typing all that. Or if it was a 9, you could print out that it was an A. If it was an 8, you could print out that it was a B. If it was a 7, you'd have to print out that it was a C, and so on. Some languages will let you stack cases together like that. Let's see if this one will. I'm going to come up here and try to stack two different grade cases. In other words, I want to see if I can make it support a lowercase a or an uppercase a in the same block. So case, double quote, lowercase a, in double quote, colon. So you see what's going on there? If either that one or that one is true, it's going to print out the 90 to 100. If either, you know, and then we could do the same thing here. Case, you know, lowercase b and case uppercase b. So the homework over this idea, and you probably have already done this if you've taken my C++ class, you seem very familiar, is if you remember the old days, if you had a keypad with the letters on it, the numbers and the letters like this. If you were going to send somebody a text message back in the olden days, or if you're so old that you remember when telephone prefixes were given in letters, like dial, you know, RE3 1 2 3 4, well, an R was a 7, you know, and a 3 was an E, and so on. So Midwest City was the regent prefix. That's why every number in Midwest City at one time began with a 7 and a 3, RE. Well, we're going to make something that takes those letters and converts them to the digits. So let's just start a little bit of that off. I'm going to get rid of that. What would that look like? We would need to ask the user for a letter. So let's create a letter string variable. String letter. We need to print a message out. CW tab. Enter a telephone prefix letter. End quote, in parentheses, semicolon. Then we'd have to let them type it in. So letter equals console dot, not conwol, console dot read line, capital R, capital L. And then based on what they type in, we can execute some switch statements. And if we look up here, if they type in an A, B, or C, in uppercase or lowercase, we wanted to print out a 2. Now it'd be neat if we could just convert that string to uppercase so we wouldn't have to worry about it. And of course we can. But for now, oh, I'm getting an error here. What did I do wrong there? You see what's wrong?
Double equals.
Double equals. Yep. Alrighty. So now we're going to switch based on that letter. Switch on the letter. And so we have several cases. We have lower cases and upper cases. Can we just do switch on letter dot to upper? Yeah, that'd help. Okay, so I've changed my switch expression a little bit. Switch, parentheses, letter dot, T-O, U-P-P-E-R, capital T, capital U, parentheses in parentheses. All right, and so case A inside double quotes, colon, case B inside double quotes, colon, case C, colon. If any of those is true, then we're going to print out 1. No, we're not. We're going to print out 2 because that's that. So console dot out dot right line parentheses quote 2 in parentheses and then break. The default is going to just say unrecognized or something like that. Console dot out dot right line, capital W, capital L, unrecognized letter. Well, for one thing, they may have typed in 2 letters. That's going to break it. Oh, look, we have to put a break even on the default clause. Here I said we might not have to, but it's requiring it. Okay, so you're going to want to fill in the rest of that. Really, it's not going to take you very long to do that, so this is really not an impressively difficult homework assignment. So that's one. That's one thing that we could do with a switch, right? You know, and then D, E, and F would print out a 3. E, you know, H and I, and so on would print out a 4, and so on. So there is no fall through. So if you're used to using fall through in C++ or C or Java, you can't do that. You'll always have to use a break statement. You can use switch statements to replace a sequence, an if cascade. If year is equal to 1, write freshman, else if year is equal to 2, write sophomore, else if year is equal to 3, write junior, and so on. And you can use multiple labels, which is what we did. Case 3 and case 4 both print upper class, whereas case 1 prints freshman and case 2 prints sophomore. You can use an enumeration with a switch statement to try to make it easier to read. If we go and Google into this code, right, enter your major. We have 4 majors: accounting, CIS, English, math, marketing. Apparently accounting isn't my major because it's actually 5. And then we ask them to type in a code. We convert it into the enum type, and then case accounting or case CIS or case marketing, it prints this out. The major is in the business decision. If the case is English or math, then major is in the humanities division, else department number is invalid. Now sure, it would be nice for us to tell them what the major codes were, right? 1, 2, 3, 4, 5 or something like that. So, but this does demonstrate using enums as your labels can make your code easier to read, right? So rather than case 1,
case 2 and case 3 majors in the business division, then we could do, you know, do these names.
And then the ternary operator. I'd kind of like to skip the ternary operator for now. There's going to be a second part of the homework assignment, but I guess I could wait and cover that on the next lecture, but y'all aren't going to be here, so why don't we take a peek at what it's going to be, get a sneak preview of it. And this will look real familiar, assignment. So we're going to write a program that lets us calculate the weight of a sphere based on its size and its material. If it's a small sphere and it's made out of water, it's not going to weigh as much as a big sphere made out of gold would be. So the way it works is we will present a menu of materials, ice, aluminum, or gold, and then we will choose the size. Is it a marble, a golf ball, or a baseball? And then based on that, we're going to calculate the density, the radius, the volume, and the weight. And so we have these tables here. A marble is that much in diameter. A golf ball is that much in diameter. A baseball is that, and a basketball is that. So the first option is going to be choosing, or one of the options needs to print out a list of the choices, and then based on what they pick, it needs to set a variable equal to one of these values in the table. Similarly, for the materials list, we have a list of about 10 different materials here. We're going to pop up a menu of them. There's only 3 in this example, but you're going to fluff it out with the entire table's worth, so that if they choose ice, the density is set to one value, as opposed to aluminum, set to another, as opposed to gold, which is another one. And these are in cubic feet, so a cubic foot of gold weighs 1,200 pounds. You see, people in movies or, or your adventure games or whatever dragging around a chest of gold. A cube of gold that's 1 foot by 1 foot weighs 1,200 pounds. You'd have to be pretty strong to drag it around. And so I had some sample code included in here that I wanted you to convert to using switch and case. But I don't see it here, so I will generate that and post it when I post the assignment. But does that make sense? This is actually, you need to know, in order to write this formula, this program, how to use density. This is all going to have to be in the next lecture. I don't know why part of the assignment is missing. To calculate weight, you have to know the volume and the density. The volume is derived from the sphere size, and the density is derived from that other table. And so we plug things into 2 equations, and we can calculate the weight. And so our program is going to let them pick which material and how big the sphere is and print out the mass of that. That makes sense? It'll certainly make more sense when I go over it more slowly in the next lecture. Good enough? All right. Except for the ternary operator, we're pretty much done with this chapter. So I need to upload the chapter 4 quiz for people to look at. I will do that. It's not going to be, due real soon since it's not there yet. And I'll let people take the quizzes over and over, so I don't put due dates on them anyways. Let's go ahead and make a Dropbox, and we can upload our stuff.